I'll find my slides 1 second. If you can see my slides now. Yep, so I'm Harry, project engineer from the WMG IV Sensors Group. And in this presentation, I'll go through a bit of background about what the Roadview project is that we're a part of. So quick one on the agenda. So I'll briefly go through what WMG's IV group is and also our subgroup, which is the IV Sensors Group, which is the Intelligent Vehicle Sensors Group. I'll go through an overview of the Roadview project, and then I'll go into a bit more details around Work Package 3, which is around sensors noise modeling, and also Work Package 7 testing in the loop, which will be a part of in the consortium. So in terms of WMG, we're an academic department within the University of Warwick. We do a variety of teaching for both undergrad and postgrad students, but also we have a large activity as a department around projects, particularly with Innovate UK, with Catapult, and also with direct contract work with the industry. WMG has several groups, such as like several research focus group, which energy, cybersecurity, digital health, and for us, we're from the Intelligent Vehicles group. And more specifically, as I said, I sit under Professor Donzella in the IV Sensors group or subgroup. So why are we interested in environmental perception sensors, or why do we have a sensors subgroup as a whole? So sensors or perception sensors are actually key for automated vehicles of the future. They are actually the first point out in which any system or any automated system will come into contact with the environment. It's the perception sensors which gathers the data that feeds on into how the vehicle can process to understand what is around them. Therefore, it's key to have a robust sensing and perception, and this is the field that the IV Sensors Group is interested in. I've got to play the videos, but on the videos on the right, you can see some of the simulations that we've created within the Unreal environment. On the top is we've got a digital twin of our University of Warwick campus, and on the bottom is a simulated world. And in here, we aim to create realistic images of environment that can be tested in. And on the bottom left there, you can also see a vehicle running in that simulated world, creating a real-time LiDAR point cloud. So yes, these are some of the activities that we work in. I won't go through them too much, but as I said, we've got our Unreal simulation that you can see on the right-hand side there, 6, 7, and 8. And we can also project this within our 3XD simulator, which is a 360-degree surround screen where you can drive a vehicle inside it. Yeah. So a quick one on levels of automation for automated vehicles, in case you're not familiar with it. So the SAE has defined 6 different levels on how an automated vehicle can perform. So it starts from level 0, in which all of the driving tasks are performed by a human driver, where the system will only provide audio, visual, or haptic feedback to the driver to warn them of something and not control the vehicle at all. And as we go up the levels, the amount of control that the vehicle can perform, the amount of control that the automated systems will take charge of increases. So it starts from level 1, where we only get lateral or longitudinal control, to level 4 and 5, where the automated system will fully drive the vehicle without the need for a human intervention. And the main difference between level 4 and 5 is that we have a term which is the operational design domain, and this essentially informs the user in which areas or under which scenarios can the automated system handle and operate as normal. So in level 4, when we're within the operational design domain, the human within the vehicle does not have to interact at all, and the vehicle will drive itself. But once outside that operational design domain, it cannot perform the same functions. Whereas level 5, it can take place anywhere. So back onto the Road 3 project, which I'm sure you want to hear about more. So some of the key facts is that we've got 16 partners that are spread across Europe in 7 different countries. On the right, you can see a map. This is actually just a map where we show in which countries we'll have testing either as a digital twin in simulation or in real world testing. So that is where some of our partners are based. So we've got the UK, which is SWMG. We have partners in France, Germany, Turkey, and Finland. And additionally, we've also got 2 more partners which we won't do testing in their country, but those are in Sweden and Switzerland. This project will take place over 4 years, and the total funding from EU Horizon is 9.7 million euros. So what is the aim of the Road Through project overall? So what the Road Through project seeks to do is actually develop an end-to-end testing and development system for harsh weather conditions. So what do we mean by harsh weather conditions? This is more like scenarios where we have heavy rain, where we have fog, or where we have heavy snow that can actually hinder how the vehicle can operate as normal. And within this, I know the right map is complex, but I'll go through it very briefly in the image. So there are 3 different pillars that we call here. And in these 3 different pillars, these are actually locations in which we can either gather data or we will perform testing in. So in pillar 1, we perform everything synthetically. So this is all within a simulated world. In pillar 2, this is where we have controlled environments such as closed tracks, or in this case, we have 2 partners, one from Germany and one from France. That's Charisma and Cerema, where they actually have indoor and outdoor facilities that can simulate or they can produce rain within their facilities and also fog. And of course, finally, we need to test in real world and we need to gather real data in pillar 3. In terms of work packages, we've got 8 main work packages. So in work package 2, it encompasses all the other work packages because this is the work package in which the technical details and the technical use cases are defined in. So work package 2 will inform the work in all of the other following work packages. In work package 3, which WMG are leading, we'll be creating simulation assets for the synthetic world, and also we'll be producing sensor noise models, and these will be both physics-based and data-driven based. In work package 4, this will be gathering data that can be used for the following work packages for the machine learning algorithms. So they'll be collecting data, annotating it, and also denoising some of the data that they collect so that it's cleaner and better for the AI algorithms. In 5 and 6, these will be where the actual understanding of what the sensor data is from work package 3 are, and using the understanding of the world to provide control. And we have to remember that these are different in that the data that comes through to them will be under harsh weather conditions, so when we have heavy rain and fog. And I believe there's also an element of V2X. So the plan is that the testing will also, or the perception algorithm and the control will include communications to infrastructure to assist in their planning. And then we have work package 7, which WMG will co-lead with Charisma, where we'll perform validation along all the steps of development, so extended loop testing. And finally, work package 8, we have a series of demonstration which we'll perform in either proving grounds or in simulations or also in real worlds. And that's where the planning and the actual work take place in work package 8. So back onto work package 3, which WMG are leading, which is around sensor noise modeling. So the overall aim of the work package as I said, is to create simulation resources for development. So this will include environmental and world models. We're aiming to capture digital twins of the proving grounds and the testing facilities. So we're looking to create digital twins of the Charisma rain facility and the Cerama rain and fog facilities as well. And also, I think there's the aim to create a digital twin of some of the demonstration sites so that we can show that we can testing in an enclosed environment, or sorry, in a simulated environment before pushing it out onto the real world. And then, of course, the biggest part of this work package is actually around the physics and the data-driven based noise models. So we'll be using the data collected and from literature review to create these models. And of course, at the bottom, you can see our approach. We have a 4-tier approach where we start with creating the environment of the simulation. Tier 2, when we start adding in noise models. In Tier 3, that's when we start combining the different noise models that are separate so that we understand what the effects are when we have multiple noise impacting the systems. And in Tier 4 is how the vehicle will drive within the environment. So vehicle dynamics is a key one because in our harsh weather conditions, especially when it's snowing and so on, we're likely to see things like icy roads and so on. So vehicle dynamics is a key part in testing in the loop because this might mean mismatches in where the vehicle thinks it is in simulation compared to real world if we don't get the vehicle dynamics right. This is another overview of just how the different work within work package 3 will, the different parts of work package 3 and how they link to each other. So we start with weather and sensor characterizations. So we'll be capturing data in the Cerama and Charisma facilities. I've got a small image of them on the left there. So the top one is the Charisma facilities where they can produce rain along the track. And at the bottom is a model of what the Cerama facility is. So we'll be capturing our harsh weather conditions within these facilities. This will first be used to create data-driven models. So we'll go through our data analysis of how the noise is impacting the sensor data and create data-driven models. And then we also use this collected data to validate our models. In terms of the physics-driven models, this will be mainly achieved through looking at literature and understanding how the physics of or the physical properties of the sensors, so how the light or how the radio waves will interact with the noise, so with the water in the air and so on, and create models based on real physics. And of course, this also needs to be validated and evaluated. And for this, we need to create comparisons, or we create evaluation metrics that will be done as part of the work package to understand what is the best way to evaluate these models against the data that we collect or against what is happening in the real world. And of course, through this, we decide based on what we want to do in the test cases. So based on what package 2, which defines how we're using, what are the tests and the use cases for it. Based on what package 2 and 8, we'll decide which model should be chosen to be used for our testing in the loop. And then there's a final point, which is, as we said earlier, compounding or understanding how noise interact with each other is very key because it's very rare to only have one noise affecting your sensor at any one time. So there's also a part of the work which we try to understand how can we compound or how can we combine noise from weather with internal sensor noise. And then this, of course, feeds through into the later work packages that's in the gray boxes. In terms of what WMG are doing, I've circled it here. So these are the work that I will be working on specifically. Will be involved in the other work packages as the work package lead, but this is these 4 boxes are what WMG will be specifically working on. Yeah, and onto work package 7, which we're co-leading with Charisma. So in work package 7, this is bringing all the previous work packages, so work package 3 to 6 together so that we can test, as we said earlier, it's an end-to-end testing and development project. So this is bringing that all into one to say, how can we test and when can we test? So of course, we want to test at every stage. So we can test in software in the loop, hardware in the loop, all the way up to proving grounds and the real world. For WMG, the major part of our work within this work package is to help define the test cases. So we'll be working with Charisma, and based on what we understand are the use cases defined in work package 2, we'll define how we can or what we actually need to do in the testing. And also we'll be taking part into providing some of the scenario generation, particularly in Unreal or in the simulation packages. So this will concern software in the software and hardware in the loop, where we're working in virtual environments. So WMG will be looking to create the scenarios for them, but bring together all the previous work packages. So from work package 3, we'll create the sensor models, some of the world models, and the noise models that are listed here. So in the blue boxes under environment, this is what is likely to be used. Sorry, the work package 3 will feed into these models that you see here. And in terms of work package 5, this is where the perception model comes through from. So it will feed into testing in this part here. And of course, work package 7, which is the control side, will feed through into there. And of course, one major part of work package 7 that needs to take place is how can we combine or put all these systems that are developed separately together onto one platform, both for testing and also for the real vehicle platform that will be tested in the proving ground. Yeah, and just finally to conclude on what the current work that's been taking place for Roadview is. So Roadview's only started last month officially. The kickoff meeting was around the 2nd week of September. But since then, what we're currently working on as a consortium before we break out into our individual work packages is defining the architecture for the software and the hardware stack. So this is key because I think we've got 4 or 5 different partners who's got different demo vehicles or different vehicles that they own inherently. And we need to align with everyone in how we want to define these, because we don't want to be developing on 4 or 5 different platforms at the same time. 2, which is the second point there, defining the use cases for the system. Again, this is a major part because this influences all the work that will take place in the work packages, because this will be defining what exactly is the harsh weather that we'll be testing, which locations are we testing, and so on, and how. So this is a big one that we are at the moment trying to agree on between the consortium. And then finally, something more specific to our work packages, what sensor suite do we need to consider for modeling? And we need to define that, because with different sensors, particularly with different sensors technology, as we try to model more and more, that might become too heavy of a workload in terms of, because we want to get multiple weather conditions and so on out. So we want to simplify this and have a common agreed sensor suite with the consortium. Yeah, and thank you. And I've got pictures of our team here and also a link to the project website that we've got live recently if you're interested in having a look. Thank you.
Harry, that's great. Thanks very much. And again, very exciting project and very relevant to see some of the names on the call as well. So I'm going to open the floor up to questions. So you can either raise your hand and ask a question or put it on the chat, and then we'll field them in the next 5 or 6 minutes. Whilst we wait, maybe I can start then. Oh, there is a Richard. Richard, thanks very much. You've got a hand raised. Let's start with you.
Yeah, let's see if my camera on there. Thanks, Harry. Yeah, it was good to hear all about that. Let's catch up. I'm just interested in perhaps my camera. So you can't see me. Perhaps interested in some of the actual models you use and how you're going to deploy them. So when you're testing and really trying to understand some of these sensors, I guess there's two approaches within the model. There's kind of the ray tracing approach, or there's the sort of actually taking it really back to how, let's say, a laser or the RF propagates in free space and interacts with the weather systems. What approach are you going to take within your models?
Of course. So I think we're trying to steer away from that side as such. So I think the focus of the work package is more surrounding the sensors noise modeling and not the sensor models itself. So I think at the moment we're trying to agree within the consortium onto which simulation packages we use. And of course, from that, they will have inherent sensors models. So I think the idea is we try to reuse that as much as we can. Of course, if when we come to the physics modeling and we decided actually to do this properly, we might need ray tracing and so on. And then that's when we might need to look into how we should do that. But of course, we're trying to keep it simple for now and trying to use what the simulation software has to offer first before trying to adapt that.
Yeah, I agree. I think it's getting that balance right between simulating everything and making it real and creating a huge problem for yourself, but also not really moving too much so it's not real anymore. And that's one of the key challenges I see going forward. Yeah, thanks, Harry.
Yeah, thank you.
Thank you very much, Andy, for that. Yeah, some more questions, please. I think some are. Okay, Warwick. So I had a question on the scenarios you mentioned about. Okay, sorry, Mark. Didn't see a hand.
I just couldn't see the raise my hand button. But just in terms of the sort of the exploitation outputs of this project, you know, how will they be made available, or you know, who will be able to use these components after this? Because you know, could be of interest in other specialist areas like ours. But,
of course, I'm happy for a chat too if you want to learn a bit more about it afterwards. I think my email's on the slide at the moment. But so in terms of exploration or exploitation and so on, of course, being an academic department at WMG or at the University of Warwick, all our work is going to be, or we try to publish all our work if there isn't any conflicting confidentiality with the partner companies, because we do have a few industry partners like Ford Otosan in Turkey. So as long as the work that we produce will not conflict with the industry partners' interests, we'll aim to make it as open as possible. I'm sorry, I can't give much more details out on that, but I think
I can understand. But yeah, it'd be interesting in this environment with simulations and things, which bits or what access there will be to some of these outputs.
So what I can add to that is before I left Warwick University, I did make sure that AESIN got a seat on the steering board. So there is a steering board for Roadview, and I negotiated with Paul Jarvie to make sure that we had representation, because it was a very exciting project. So now that I'm on this side of the fence, hopefully I'll be joining those steering board sessions and being able to voice the view of AESIN members, to give input, sort of an industry view of what the needs are, and equally become a conduit for anything that is then shared out publicly, that we can then make sure that our AESIN membership gets first dibs on that sort of stuff as well. So we have a man on the inside, hopefully. And so if you are interested, you know, please drop me a line afterwards if you're interested to get more information or be in some way linked with the project. So I had a question on scenarios. So what's the strategy behind understanding which scenarios will be used or how you develop the scenarios?
That's a good question. So
That's a hot topic at the moment around, how we develop scenarios. So I thought,
yes, of
I'll put
course.
you on the spot.
In this regards, I think this topic is touched upon or is actually going to be performed in Work Package 2. So I don't have as much knowledge into that, but I think it's one of the Swedish partners that will be looking to define them at the moment. I think they're looking at like referencing, understanding what I presume they'll be looking at what conditions are they interested in, particularly for their area, because they understand what harsh weather looks like for them more than what we can from the UK, because it's quite a different climate from there compared to us here, especially in the Midlands. So I'm sorry, I'm not able to provide any more information around that.
Okay, no, that's fine. I was just curious. Good, thanks. Thanks, Harry, for answering that. So more questions. I think we've got a minute or two left. If there are any more questions, please post them now. We'll jump in. Okay, so in the absence of more questions, then Harry, I just want to thank you very much for fairly short notice jumping in. A very interesting topic. I think it's a very, very hot topic, and there's a lot of opportunities for us to be doing stuff in the UK. It's something that we're going to build on with the Sensors Interest Group that Valentina runs, and we're going to hopefully, as the project matures, Valentina has plans for creating workshops where you'll all be invited to join in to discuss some of the work that's going on here and also then contribute. And my view or vision is that we could do something in the UK that's almost a parallel, and we can use this as a platform for doing bigger things in the UK and certainly exploit the AESIN membership base. So with that, I also want to thank, somebody's just joining a bit late. I just want to thank everybody for joining, and also for those that put questions across. As I said, if you want more information to get more involved with the Sensors activity, please drop me a note. And Valentina is here anyway. You can drop Valentina a note directly as well, and we'll make sure you're linked in there. On a final note, our next technical talk is scheduled for the 3rd of November. It is an open slot, and if you'd like to nominate somebody from your company, it's a great opportunity to get young engineers and researchers, like we've just done with Harry, on a stage to come and talk and present some of the work they're doing. So please drop me a note if you have some ideas. It's a great way to get your company also, well known to the membership base as well. So drop me a note with an idea of what you might want to talk about, and we'll plug you in to one of the future tech talks. Okay, with that, so thanks very much. Have a really great afternoon, and we'll see you soon. Take care. Bye-bye.
Thank you, Vinny. Bye-bye.
Right.